Hello, everyone. Thank you for joining us today. My name's 𝗦𝗲𝗀𝗀𝗻𝗀. I have kind of a dual role at Microsoft. I both lead the product for our apps and agents platform for our core AI organization, but I'm also the general manager for our internal engineering systems team. And so what we do is we basically take all of the products that are targeted at developers that you all can use, Visual Studio, Visual Studio Code, GitHub, Azure DevOps, and we host them, manage them, extend them, incubate in them for Microsoft's internal audience. And we really support developers across the entire company, so tens of thousands of developers building things like Microsoft Office and Azure and SharePoint and Xbox and you name it, they are using our stuff. So I'm super excited to be here today to talk to you about kind of our story in terms of how we are adopting AI throughout the software development lifecycle. And I would say that this has been an incredible journey over the last couple of years, but at the same time, I really feel like we are only in the early innings. And so what I'm going to share with you today is the progress that we've made, how we're thinking about it, how we're approaching it, and hopefully show you a couple of demos of real actual experiences that are available for engineers inside of Microsoft today that illustrate how we are approaching all of this. So let me just first start with the idea that every major leap in human productivity has really followed a similar pattern. There's a technological breakthrough, and then it rewrites how we build. Cromford Mill wasn't just a new factory. It was the first time that water-powered machinery replaced hand labor. And it was a breakthrough that really created the world's first scalable, repeatable production system. Erie Road applied breakthrough steelmaking technology to create a continuous flow, moving from raw materials into finished goods without stopping the production line at all. And Ford's moving assembly line was a breakthrough in motion design, which really compressed the build times from hours to just minutes. And obviously, the entire industry is pretty obsessed with Toyota's lean production systems, which brought breakthroughs in sensing and feedback and learning factories that got smarter with every single cycle. And so just like every leap in industrial productivity started with a technological breakthrough, we're actually living through that moment again. A couple of years ago, we only had a handful of foundational models. Most of them were from OpenAI. They were powerful, but they were limited. They were great at language, but they really weren't thinkers. They weren't reliable tools users. Over the last 2 years, there's been an absolute explosion of these foundational models from OpenAI, from Microsoft, from Meta, Google, Anthropic, and a wave of small and specialized models as well. And with them has come this new capability, abilities that are going to change what software can do. They can reason, they can plan, they can use tools, they have memory and grounded actions. These aren't just smarter models, they are the ingredients that actually make for agentic workflows. And it's those agents that can then understand the context and break down goals and call APIs and take action and collaborate across the entire development lifecycle or any workflow that you're working on. And so just like past revolutions needed their breakthroughs, their technological breakthroughs, water power for Cromford Mill, or motion design for Ford, or sensing and feedback loops for Toyota, these agents need these new model capabilities. And now we have them. So what can we do with it? You know, in 1975, Bill Gates and Paul Allen imagined Microsoft as a software factory, building the tools that really powered the next 50 years of computing. But now, in 2025, we're entering a new era. Year 51 and beyond is going to be defined by Microsoft actually becoming an AI and agent factory. So breakthroughs in reasoning and planning and tools calling and this explosion of foundational models are changing the physics of software development. What we used to think of as manual steps and gated releases is shifting to a world where agents collaborate throughout the entirety of the software development lifecycle, where the systems can learn and improve on each cycle, and every team works side by side with agents and collaborate with them. So this talk is about that transformation, about how we are reshaping our engineering systems for the future of modern software development, and we're just going to show you example after example. So this isn't theoretical. Many teams at Microsoft are already making this shift from a software factory to an agent factory, building agents. These beacon teams across Microsoft are really creating a blueprint for how the whole company is going to build going forward. Here's one example. This is the Dragon Copilot in healthcare. Basically what it does is it allows doctors to speak into their computers, and that then transforms that into the notes. We've all had doctors' encounters where the doctor's face is sucked into the machine and they aren't really interacting with the patient. This is really to address that challenge, right? This Dragon Copilot in healthcare is an example where we're trying to kind of improve the voice detection recognition, and this is obviously a very specialized field. We have to kind of, there's all these specialized terms in the medical industry that we have to recognize. And so we're trying to kind of take care of these tight schedules, the heavy documentation requirements that doctors have, and competitively, we're also seeing a lot of pressure in terms of AI native competitors that are also trying to participate in this space. And so speed and quality of the engineering systems and the agility of the software development is really, really critical. And so this team really embraced this agent factory model. They started with models that were fine-tuned on clinical data that they had collected. One of the first dimensions that you have to do as you are building your own machine learning model or your own agentic process is you have to collect and curate all of that data. They then improved them with the real physician interactions and expert review, and they grounded it on over 40 million encounters between doctors and patients. And they continue to validate every change that they make through these rigorous A/B tests. And GPT-4, which was last year, really wasn't ready for clinical use on day one. But through this continuous learning loop, they've reached 83% physician acceptance, which is significantly better than where they had started. And that's really the power of this agent factory, these systems that can get smarter with every interaction. So Dragon Copilot is a great example of this new model of software, where you don't just ship once. You actually build the systems that learn, and that mindset is now reshaping all of our tools, our workflows, and our engineering practices across the entire company. And we can see in the advances that the foundational models are making, we are also evolving our tools. So if you look at GitHub Copilot, you can see us moving from tools to collaborators to agentic systems. We began with code completions, which really accelerated the inner loop. It reduced the amount of typing that you had to do. And then we introduced GitHub Copilot Chat, which allowed developers to ask and explain and refactor in natural language. And then agent mode enabled multi-step execution, running tasks, calling tools, navigating your repo. And now, as we're entering the era of the coding agent, it's really an asynchronous and sometimes fully agentic developer that can plan, analyze, code, test, and iterate. And obviously, we still believe that there needs to be human supervision over all of these agents. So they come back just like any other human would in your code base for a code review for anything that you want to check into production. But this is really the progression from an assistant, the AI as an assistant, to being a partner, to actually being an autonomous collaborator that you can dispatch work to. And it mirrors our own shift from the software factory to the agent factory. So to understand why this matters in the context of Microsoft, you have to look at the scale and the diversity of our code bases. We have brand new services that are built in the last 18 months that power a lot of our latest AI products, but we also have code that's been running for decades. Sometimes multiple decades, like the Excel kernel or things like that. And it really represents layers and layers and layers of history of decisions that we've made and insights that we've gleaned from millions of customers using our product. Some repos have a handful of engineers working in tight loops, and others have thousands of developers collaborating inside really what we would call a mono repo. But between those extremes, we have every language, every architecture, every lifecycle stage that you can imagine. And I think this is one of the things that's really critical. A lot of times people in the industry talk about these AI native teams, but their code bases are like 2 years old at most, right? They're not dealing with the complexities that I know that many of you are dealing with in terms of managing legacy code bases, technical debt, et cetera. And so Microsoft itself also reflects that. We have old and new, we have big and small, we have cloud native, we have legacy, we have mission critical software, but we also have experimental software that we're working on simultaneously. And sometimes these things are actually in the same code base. They are actually in the same repo. And I know that this mix is not unique to us. I know that this reflects the reality that many of you all face in your teams as well. But when we map this shift into the DevOps loop, we see this opportunity to bring these agentic capabilities throughout every phase of Microsoft's engineering systems. So collaboration is no longer just developer to developer, it's developer to agent, and increasingly agent to agent, so that you can work together to plan and code and build and test and deploy and operate our systems. And we're already using autonomous and semi-autonomous agents throughout the software development lifecycle to handle routine engineering work, to manage complex analysis and remediation, to improve code quality and security, to compress the cycle time overall, to reduce the operational burden on teams, to address massive amounts of technical debt. I think a lot of people look at that and they're like, okay, developers are getting replaced. I do not believe that at all. I think that developers are becoming agent bosses, right? They are orchestrating the workflows, they're guiding the intent, they are overseeing the decisions, and they're spending more time on the design and the innovation and the product thinking, and they are increasing their learning cycles, their ship to learn cycles. That's what we do at Microsoft so that we can better support all of you. Now, the user experience that we're aiming for is to have an agentic end-to-end software development lifecycle, a world where agents expand both the inner loop and the outer loop, where they work with us synchronously and asynchronously through every phase of engineering. Now, one of the things that I want to introduce you to in this concept of platform engineering, where basically we are a centrally responsible team that is our mission is to improve the developer experience at Microsoft, to drive standards and compliance and things like that. We really have a few different motions that we focus on. We want to make sure that all of these capabilities become repeatable and reliable for every team at Microsoft and ultimately for every enterprise. And so what we focus on are providing these paved paths that are fast and secure and consistent and scalable and compliant with our regulatory requirements that also give the developers the room that they need to innovate. And so we think about this through three core motions. First is start right, turnkey project foundations, templates, policies, guardrails, and best practices that are built in from day one. Stay right, the ongoing motions that keep your app estate healthy. So enforcement and security and compliance and cost visibility, and the operational hygiene as your code really drifts from the first time that you create it. And then get right. What you can think about here is that our standards are constantly evolving because we're learning. There might be a new security vulnerability that we've just identified, and we need to update the entire code base. I can say the word log4j, and everybody in the room shudders because we all know what pain we went through to respond to that incident. But that's a great example where you then have to go drive a campaign across the entirety of a code base to make sure that you're all compliant with the latest standards. And so these three motions are really what also make agentic engineering practical at scale. And so today we're going to show you an illustration of how we can tackle each one of these motions through demos and kind of deeper discussion. So to start with, let's dig into Start Right templates, which cover workflows and config as code and the foundations that lead to faster and more reliable operations. And so what we're going to do is we're going to use an illustrative example, which is Seeing AI. Seeing AI is, in some senses, we had to pick a project that was relatively low security risk to us to illustrate all of these concepts. And so we thought Seeing AI was a good example. But Seeing AI is a fantastic app. It helps the blind basically navigate the world using our AI technologies. And so as you're traveling throughout the world, you can take a picture of anything that you see, and it will, in your earbud or on your screen, tell you what is in front of you. And so it uses AI to describe the people and the text and the objects and the scenes in real life, and it really tunes that visual information into insight. So a user can point their phone at something and say, what are the vegetarian options on this menu, or what color is this shirt, or other things like that, and it will tell them what they see. And so as we walk through Start Right, Stay Right, and Get Right, you're going to see how each one of these different motions plays out in the journey of Seeing AI. So to get to that next demo, I'm going to invite Karl Piteira up here to show you an illustration of this.
Thank you, Amanda.
All right, there you are. You already came on.
OK, so before we start, I want to explain two key standards of the Microsoft engineering system. One of the foundation of our Start Right and Stay Right is pipeline templates. Think of these as secure and up-to-date blueprints for building and releasing software. They're versioned, centrally managed, and every team inherits from the latest best practices. That way, our engineers are not reinventing the wheel or missing critical security steps. These templates run on 𝗦𝗲𝗀𝗀𝗍𝗃 hosted pools, which are build agents that are hardened, managed, and always ready for large workloads. The goal is to make it easy for every team to do the right thing by default and to focus on delivering value, not wrestling with infrastructure. So let's get into the demo.
You need to switch.
In this demo, I will play the role of a new engineer on the Seeing AI app. Seeing AI, what do you see?
I see a developer with funny glasses pretending to be a developer for Seeing AI.
That's me. So as I start as a new team member on Seeing AI, I want to have a maximum impact. But I'm lucky because my manager asked me to move our backend to production using pipeline templates and hosted pool. The problem is I'm new, and so I know nothing about the Microsoft policies, the YAML schemas, the templates, etc. But thankfully, we have ES Chat. I can access it through a VS Code extension and just prompt it. So here, for example, I am asking it to research what 𝗦𝗲𝗀 pipeline templates are, what 𝗦𝗲𝗀 hosted pools, and then to explain to me in details all the benefits, the security features, etc. Because, I don't want to go blindly do something that I don't understand. I want to learn and grow. And so ES Chat will help me with that. Then I wanted to explain all the steps in order to perform that migration. And finally, and you'll see why, I asked it to prepare a work item in order to do some work. So there we have our results coming in with some explanation. And of course, in real life, I would go much deeper. I would ask more questions, ask more about all of these standards, the benefits, etc. But here we at least already get an overview. So it responded. It's been trained on our documentation, our knowledge base, and a number of skills that we've prepared specifically based on our engineering system baked into the system. So it prepared a work item, and now the next step for me is to use our MCP server in order to actually go and create that work item in our system. And you guessed what? I'm going to assign it to Copilot coding agent in order for it to do the work. So it's going to take a bit of time, of course, because it has to provision the agent and do the work. So I'm not going to leave you waiting. Even though the work item is created here, the implementation would take some time. So we'll give it a few minutes. And I have already here prepared a pull request, which is the result of that work item executing. So as you can see, it did everything that I asked. It has the official pipeline templates, all the security tooling that I asked, etc. It even wrote a short documentation about all the things that it did, the files that it modified, all the security tooling that it implemented. And that is critical because The problem is that until now, we've had to rely on tribal knowledge, asking people, like, how do you do that? Where do you find the documentation? Wrestle, like, spend half a day finding that, probably try a few times and fail a few times until we get it right. And we're talking about putting things in production, right? So having that support of an agent helping us fast track to the right place where to find the information, and actually successfully having that written was critical for me. So like I said in the introduction, sorry about that. Like I said in the introduction, setting up the best practices from the start and then having them enforced through those pipeline templates is critical for our engineering system and helps all our developers do the right thing by default from the start, and that starts right. Thank you.
Awesome. Can you switch back? Thanks. All right. So what Karl just showed you is the start right in the context of ES Chat. Now, ES Chat he used in the context of just start right, but it's also used very commonly for just troubleshooting or provisioning some infrastructure that you might need, like a new dev box or something like that. And what we find is that developers on average save 46 minutes per task for anything that they go to ES Chatware. And if they become kind of a regular user, they save about 98 minutes a day. So if you think about the impact that that represents at the Microsoft scale, that's pretty massive. Just in September 2025, and we're still in the process of getting this to be broadly used across Microsoft, we saved over 2,000 hours worth of time, developer time. And at the end of the day, like, this is not the kind, nobody really loves as a developer to go hunt and peck throughout engineering wikis, right? In some senses, what we're doing is we're bringing engineering wikis to you through the chat experience. But even further, you can then take actions based on the infrastructure because we are exposing all of our infrastructure as MCPs, as APIs that can then be invoked by the agentic processes. So let's just talk a little bit about how this is built. This is really, it's an agent. You guys could go use Microsoft Foundry to build the equivalent thing for your environment as well, and then plug it into GitHub Copilot. And so what we've done is we've taken the traditional Microsoft wikis that we've always had in engineering wikis, and we used that as a knowledge base that we ground our agent in. And then we also expose all of our infrastructure like DevBox and our cloud build service and our cloud test service. And really all of our dev infrastructure we expose as MCPs, which are tools that can be called by ES Chat. And because the ES Chat agent lives in VS Code and anywhere Copilot is, but it also lives in Teams, the developer can really access it wherever they are working, right? And so, you also saw him assign the process to the GitHub Copilot coding agent, which is essentially our asynchronous agent that can do work on your behalf. And it can do all kinds of things for you: bug fixes, feature implementation, rule-based changes, template creation, library upgrades, optimizations, accessibility fixes, technical debt like migrations from .NET 6 to .NET 8 or from Java 8 to Java 21. And what we see is that it improves the performance, the time elapsed by 30 minutes on simple tasks, 4 hours on medium tasks, and Jenny will talk about in a second about how it's having much more significant impact on things that you really kind of orchestrate all together. It can save weeks and months of time that we've seen. So, what we're seeing is that overall, this is having a huge, huge, huge impact. Now, the next thing I want to show you and that Karl and I want to share with you is how we think about stay right governance. We need to think about incident monitoring and if there's a new incident that comes in, how do we respond to it? And how do we learn from it so that the entire organization can actually improve our code bases over time based on it? So you want to go ahead and show them?
Yeah.
Thanks.
OK, so now we've deployed our backend to production, and it's real time. And as much as I'd love to say that it's flawless, in reality, that's not always the case. Here, we all know that in the real world, incidents happen, and sometimes at 2 a.m., right? And the one thing that I value is my beauty sleep. But thankfully, at Microsoft, we have the SRE agent that is basically our AI-powered teammate because it monitors our production environment to detect issues, and it can even propose or automate fixes. So the goal is that our engineers can focus on building, not just firefighting. So let's take a look at the SRE portal. So we have here some incidents indeed that happened, and I'm going to pick one of them. OK, so this one didn't happen at 2 a.m., but I was coding in the flow at that time. So first thing first, it acknowledged the incident, and then it built a plan. So let's take a quick look at the plan. So it's extracted the error, found the stack trace, and then created a GitHub issue. And that's the important part that we are going to take a look at. So I have that GitHub issue here, and in our code, we had actually a buffer overflow that was not managed. So as you can see, SRE agent prepared a very detailed GitHub issue with a detailed description with the stack trace, the source analysis, so all the files that it looked at to find the problem. Most importantly, the root cause, and that's one mistake that most developers that are starting with AI do is not really going and asking and prompting the model for root causes. And so here, of course, SRE agent goes deep to find that root cause. And we see here that it was, in fact, the client sending an image that's too big for the backend to manage. Then it provided some recommendations. And you guessed what? We assigned that issue to Copilot coding agent to actually do the work. And we can see here, again, I have a pull request prepared in advance for that with the exception that's caught and sending the right HTTP payload so that the client can properly react instead of failing silently. So before we end the demo, I just wanted to show you how the magic happens. And we have here, and that's one very important aspect of the SRE agent, is the ability for our developers to build sub-agents that will be executed by that main agent. And so we have here, for example, a sub-agent that we created for that buffer overflow. And we can create more. For example, we could have a sub-agent for deployment monitoring in order to check everything that happens at deployment time. And then we prompt it correctly with all the detection criteria, everything that needs to happen, et cetera. And of course, that agent will have end-off instruction for the next steps, potentially other sub-agent to hand off to, and of course, the ability to choose from a very wide library of tools that it can use in order to improve the detections or to take action after that. So this is one of the ways that we can extend and expand the SRE agent to be even more powerful. So this is how we improve our engineers' sleep, having an SRE agent monitoring our apps in production and reacting 24/7 under the supervision of our developers. Thank you. Back to you, Amanda.
So what you saw there with the Azure SRE agent, it is available to you all. You all can use Azure SRE agent as well. We just showed you the internal-facing interface for it as opposed to the externally-facing interface for it. SRE agent is a great example where it actually started with a hypothesis from our internal engineers, which was that we could use agentic execution and agentic AI to improve the quality of life for our SREs and for the teams that support the underlying services. And essentially what we did is we took the knowledge bases that we were handing to the SREs in terms of training material and troubleshooting guides, and we just codified them into the knowledge base that now an agent can go react to. And over the last few months, we've had over 7,000 incidents that are handled entirely autonomously. Obviously, all of them end up with complete audit trails so that we can actually go after the fact, understand what happened, and is there any kind of root cause remediation that we need to also implement. 18,000 incidents where diagnostics were auto-collected. This is super important. For live site incidents, if you think about it, if it happens at 2 a.m. in the morning and you have a mid-level engineer on that, it's a lot of pressure. It's very high complexity. You're dealing with complex services. And so anything that we can do to both just reduce the amount of anxiety and pressure for the engineer, but ultimately improve the mean time to mitigation, that's absolutely huge. And so the result of this SRE agent being deployed for our Azure services is over 10,000 hours saved for these on-call engineers, many calls that just didn't have to happen as a result of the SRE agent being able to monitor these environments. Now, we also have the GitHub Copilot code review capabilities, and so we have over 90% of our pull requests are now covered. We see this contribute to a 10% improvement in the PR completion time. One of the things that we look at is basically that friction that developers experience in their engineering systems, where the engineer, if the build time takes too long, or there's flaky tests, or the engineering team doesn't have a great culture around responding to pull requests, that kind of creates a crummy experience as an engineer. And so we really want to kind of make sure that we are continuously improving that kind of thing. So now let's turn to our third motion, get right alignment. And this is really a good example of something that happens as organizations get more mature, have more people in them. You need to start thinking about the entire code estate that you manage. And you have shared libraries that are used throughout your organization. You have to improve the security. You want to eliminate the drift. And you want to make sure that you're moving the teams continuously to common standards. And in a way, it's taking care of technical debt across the entire organization. This is the kind of stuff that everybody knows they need to do, but they may just not have a real practice around how to do it, or they just find it to be very challenging. And what happens is, as a result of not thinking about this centrally in a platform engineering kind of mindset, a lot of times people just create thousands upon thousands of tickets that they then go and issue to developers to go deal with manually. And so I think AI can really change that dynamic. I think we can actually go and do more work centrally so that we don't have to have quite as many tickets, or at least the tickets don't require as much time to resolve for the individual engineers. So to show you what that looks like in practice, I'm going to invite Jenny on stage. Jenny is an engineering manager of the Entra SDK, which is our authentication for services. And she recently led an effort internally to modernize a very commonly used library across Microsoft. And it uses the coding agent to help hundreds of teams upgrade really quickly, safely, and with far less manual toil than ever before. Now, when I met Jenny a couple of months ago, and she told me the story of how she was using AI to do this, I found that she had some really surprising insights in her experience, and so she's going to share with you what she's learned.
Great, thanks, Amanda.
Thanks, Jenny.
Let's start with a quick show of hands. How many of you have used AI and been really, really disappointed? Okay, a few of you. And how many of you have tried a one-line code change with AI and ended up with multiple files changed, totally unrelated to the one-line code change? And how many of you have seen an increase in developer toil as a result of using AI? I did, but I was desperate enough to keep trying. Here's what I was up against. I own one of Microsoft's hardest security standard to adopt, Entra SDK, authentication for services, validating over 7 trillion requests per day. You probably own something like this too, that one library that everyone depends on. Authentication, logging, data access, scattered everywhere. And when there's a security incident, we all know what happens. You have to move fast. Updating the library, easy, we ship it. Updating tens of thousands of services, that's the nightmare. And here's what I'm dealing with when I'm trying to do that. CISOs want faster migrations, developers don't want to touch high-risk security code, and they definitely don't have time for more work. Management wants velocity, my own engineering team is drowning in support questions, and everyone blames me because I own the library. I'm pulled in all different directions. So when we ship version 2 of Entra SDK, more secure, but with breaking changes everywhere, I knew we were in trouble. Tens of thousands of services need to migrate, 4 to 6 weeks per service. We're making security better, but the migration cost and the developer toil is massive. So when everyone kept saying, just use AI, I thought maybe that's the answer. I went all in. I bet on AI solving the migration problem. We designed V2 to be agent-friendly. We restructured our docs. We wrote an 800-line specialized prompt for a pull request agent, moving code from version 1 to version 2. We broke down the migration into 8 transformation areas around 40 specific patterns, package updates, code registration, configuration schema updates. But it's not just find and replace. There's conditional logic. Remove the cache unless there's a distributed cache. There's sequencing. Get the middleware order wrong, authentication breaks. There's security validation, which we can't get wrong. Layers of complexity. This is why the adoption of our new library takes developers weeks and sometimes months to complete. The initial PRs came back 30 to 40% accurate. Accuracy was only part of the problem. The PRs weren't just incomplete. The AI was making changes that looked right but weren't, throwing everything but the kitchen sink at the problem. The AI removed and added code not even related to the intra-SDK migration, and it was missing the security requirements we couldn't afford to miss. And we couldn't figure out why. That's when I got desperate. We were running out of time. The pressure was heating up. So late one night, I was out of ideas. I did something different. I stopped asking AI how to fix the code, and instead I asked Microsoft 365 Copilot, how do we fix the process? And it told me something I wasn't expecting. It said, you're treating AI as a tool, as automation. That's why it's failing. You need to treat AI as a partner, as a teammate. That wasn't a technical answer. That was a relational answer. I had Copilot rewrite the prompt to reflect that partnership. Here's what it wrote. You are not a script executor. You are a co-creative engineer. Use your judgment, stay curious, and act with care. Not more instructions, not more detail. Copilot changed the relationship with us. The output changed. It started reasoning through context, flagging uncertainty instead of guessing, different mode of operation, different results. Partner, not tool. And that's when everything changed. Now we could iterate together. Remember those 8 transformation areas, 40 patterns, layers of complexity? A few small adjustments to the product, the docs, and the prompt, and we were consistently hitting 80 to 90% accuracy. We tested it on hundreds of PRs across dozens of code bases. The pattern held. Same migration, same patterns, different relationship. Less than 2 hours, for what used to take 4 to 6 weeks, the AI provided PRs, which updated the packages. The AI kept the right dependencies, removed the obsolete one. That's the tedious work developers hate. The AI changed the configuration to the V2 format. This is the kind of exploratory work that takes developers days. Reading documentation, figuring out what to keep, what to remove, what to transform, asking my team for help and our very long support queue. The AI did it in minutes. And it flagged when it needs the human. The AI can't tell from the code which types of tokens are accepted. It can't and shouldn't make that type of security decision. The human stays in the loop. The agent can migrate hundreds of code bases using the same framework. Instant context, applies the pattern, adapts to what's unique, no ramp time, no cognitive load, weeks, even months of work automated. Once we cracked that partnership model, I asked, what if we scaled this across the entire lifecycle? Today, intra V2 migration, the coding agent creates the PR and hands off to a specialized code review agent. The code review agent reviews the PR. The developer iterates, reviews, and merges. Once the code is deployed, we have an Azure SRE sub-agent specialized for intra-SDK adoption or migration, which once the code is deployed, it will monitor telemetry and then will alert on regressions before they become incidents. Not one AI doing everything. This ecosystem of specialized agents, this is Agentic DevOps. The future isn't about AI replacing developers. It's AI removing the cognitive load so developers can focus on what actually requires human expertise. It's about developers and AI working together to build something neither of us could have built alone. Remember that room full of raised hands? Some of you disappointed like me. The technology didn't change. What changed was a question I asked. Not, why isn't this working? But what do you need from me? We changed the relationship, and that changed everything. And with that, I'll turn it back to Amanda.
All right, thank you, Jenny.
Thank you.
So as we shift from a software factory to an agent factory, one question always comes up: how do we measure impact? And so we really look at it across 4 different dimensions. First, activity. Let me just go back really quickly. What agents actually do is the coding, reviewing, the testing, debugging, the hands-on motions that once consumed human cycles. Second is the output, the artifacts that they produce: commits, files changed, review commits, summaries, really the real work that moves throughout the system. But really what we need to be focused on is the outcome and the impact. The outcome are the improvements that the team feels right away. The faster PR throughput, the shorter time to first PR, fewer toilsome tickets that they get, reducing the dwell time of PRs, reducing the complexity, improving the satisfaction for the developers on the team. And then impact, the results that matter most: reducing the developer toil, improving the focus, lowering the engineering costs, improving the time to ship so that we can have those fast learning cycles. This is really the full stack of and value of the agentic engineering system, moving from keystrokes to PRs, ultimately to business outcomes. And it's why we think that the future of software development isn't just faster, it's smarter, it's more resilient, it's more secure, and it's fundamentally more human. Now, one of the things that we talked about at GitHub Universe a couple weeks ago is that Copilot Coding Agent is now a really standard part of the workflow inside of the GitHub team. It's actually become both the #1 and #3 contributor to the overall code base, right? And this is actually not unique to just the GitHub repo. If you want to see what this looks like in person, you can actually look at Microsoft's open source repositories. .NET Aspire, I think, is a fantastic example of this. You can see David's LinkedIn post where he's really thinking about and talking about how he thinks about this agent factory vision that's very similar to the way that Jenny talked about it in terms of the library migration. And also I want to give just a huge congratulations to David and the Aspire team for shipping a new version of Aspire last week. But if we look at some of the teams that are more forward-leaning in terms of adopting Copilot, you can see that across Aspire, across the agent framework, across VS Code, across the Roslyn team, which is kind of the language service that underpins our C# developer experience in Visual Studio and VS Code, GitHub Copilot is actually becoming a very, very significant contributor to these code bases. And even this is not a good it's a massive undercount of the impact that we have in terms of using AI throughout our systems, because this only represents the tasks that were assigned to Copilot, as opposed to Copilot being used in the process of doing that software development in a synchronous context. This doesn't include all of the PR reviews that we do, all of those kinds of things. So just showing illustration of just how impactful this is becoming. Now, it's pretty significant. Obviously, it's #1 contributor to GitHub, but we're also seeing the migration time really improve, moving from .NET 6 to .NET 8 in just hours. The Quantum and Discovery team reducing their Java Spring migration by 80%. And across the company, we're seeing generally about 88% reduction in modernization time. And in production, as I mentioned, the SRE agent has saved more than 10,000 hours by resolving these tickets and meeting these SLAs autonomously. So this is really an example of the power of Agentic DevOps at scale. Hopefully this gave you all a little bit of inspiration. Obviously, I think we are in the midst of this journey. I expect next year we're going to have pretty unbelievable results. I'm very excited as we now, with everything that we launched at Ignite, we now can really connect both our engineering systems with our productivity suite as well. And so I think that's also going to be pretty massive unlock for us from an engineering systems perspective. So thank you for joining us today. We'll be up. We're happy to take any questions that you have after this session. Thank you all.